Hello, everyone. My name is David Spieldunner. I am the PlantPredict product manager here at First Solar, and I just want to thank everyone for joining us. In today's live webinar, we are joined by Jacob Jackson from Pinegate Renewables, who's going to demonstrate how PlantPredict's SDK and API can be used to create a competitive advantage by automating the optimization and monitoring of solar assets in a fraction of the time it would take to complete with other software solutions. In this webinar, we will observe a live demo and real-world case study of how PlantPredict's SDK and API can be used to monitor operating solar assets. By incorporating weather station data via the API, we can compare as-built simulated data to actual energy predictions. We'll also learn how PlantPredict's exclusive automation features can save countless hours and reduce human error by completing all of the calculation models and algorithms necessary to process data, manage asset libraries, and run complex utility scale predictions. We will also learn how to achieve optimized results and ROI by running a much larger set of automated predictions than would otherwise be possible conventionally or manually. And we also are going to be making a special announcement at the end of this webinar. So that's a little bit of a tease that you're going to want to stick around, and we will also have a live Q&A session at the end of the webinar. If you have any questions or issues, please submit them using the chat or the questions feature in the GoToWebinar platform. Today's webinar will be recorded, and we'll send out a link to that recording to all attendees afterwards. All right, before we transition to our presenter, we have a quick poll question for the audience. So look to your screen and we'll get you the poll question. So first off, how familiar are you with Python? So we'll give you a few moments to answer that question, and then we will look at the results. All right, can we see the results? Let's share the results. All right, so it looks like most of the attendees are novice, although we do have a few intermediate and advanced in here. So for those, no experts. So I guess Jacob is our lone expert in today's webinar. So, all right, so that looks good. All right, with that, I think we're ready. Jacob, I think it's all yours. Why don't you go ahead and take over?
All right, great. First question, can you hear me okay? David, want to make sure my audio is good.
But you sound fine.
Okay, perfect. Yeah, thanks, and glad to be here with everybody. As David mentioned, my name is Jacob Jackson, and I am a pre and post construction engineer for Pinegate Renewables. And I've worked for, I don't know, quite a few years now on, utility scale solar, energy modeling, and the like. So I have a decent amount of experience creating yields, 8760s, all of that, and I'm really excited to show you what PlantPredict can do, PlantPredict and particularly the API and SDK. So just kind of as a level set, I have one slide in case there's kind of anybody new here to PlantPredict. PlantPredict, it's a sophisticated energy modeling software, and it's designed for utility scale solar PV. It's made for quick, accurate predictions. And so at least as far as I've seen, kind of in a little bit of contrast to other solutions out there, you can make very quick turnaround for estimates. Okay. So we're not going to focus as much in this webinar on kind of like a 101 on energy modeling or anything like that. We're here to talk about the API and the SDK and what those can do for all of us in the industry. And so to start, a few technical terms that I wanted to get out of the way, because I know throwing around acronyms and letters and whatnot can be kind of confusing. The first on that left side is a GUI, so a graphical user interface. You probably have heard this term in reference to other things. A GUI is just something that you as the user interact with. In the case of what we're talking about now, It can be thought of as like the top layer of graphical software, and it's really designed for point and click. Anything you, like the browser that you use, Google Chrome, if you use Microsoft Edge or Firefox or whatever it is, all those are GUIs, browsers are GUIs. And what those do in general is you click a button, and that button has tied to it some sort of command. And you click the button, a request is then sent to a server, or whatever it is, if you're on Facebook, if whatever you're on, it's sent to the Facebook server. The command that you clicked on is then crunched, the numbers, the database is accessed, you know, all of that really nitty-gritty stuff is done. And then you get a nice package returned to the front end. And then let's say you clicked on, you're in Facebook and you clicked on your friend. Well, then what is returned is your friend's profile. So that's kind of the interaction between the GUI and the API of whatever you're working on. And the GUI can be thought of, and I might say during this webinar, can be thought of as the front end of PlantPredict. The API, I already kind of got into that a little bit, that middle column there. That's the application program interface. That can be thought of as the heart of an application. It's a set of functions. It's a database where all the information is stored. It's all of that, you know, the terabytes, gigabyte, whatever it is of information that exists for an application. And it typically requires an additional layer for humans to use, because for most of us out here, it's hard. It's hard to interact with an API. And so that's where the GUI comes in. You put the GUI on top of the API, and those two work in tandem. And that can be thought of as the back end of PlantPredict. Finally, the SDK, which is over there on the right side, you don't need an SDK to interact with an API, but what it does is it can be written in really any programming language, any scripting language. And in this case, we use Python, which is one of the most popular languages out there. But it makes it's an alternative to a GUI, and it makes it really easy, and well, easy relatively speaking, you have to know the language, but it makes it really easy, really sophisticated, really savvy to interact with the API. And it's a toolkit or a library of functions that allows a software developer or a software dabbler to access the application's functionality with coding. And as it says there, it's an additional external software. So with that being said, those are kind of the technical terms that what we'll be talking about today. Now we'll move on to, I have 2 slides here that kind of show you that interaction and how it works. So here you have the API, and the API PlantPredict, because that's what we're talking about today. And within that, you have all of your complex functions, you have your databases, like I mentioned. On top of that, you have your GUI. And if you've been in PlantPredict, you've seen all these buttons. You have your run prediction, you have a generate module, you know, any functionality within the program. Now, let's say you wanted to run prediction. So you click on run prediction. Well, that request is then sent to the API. Run prediction is run, and that's exactly what it looks like in the back end. And then you get your result. The response is then sent to the GUI, and you get to see it. You get to see the nice, pretty graphs. You get to download the nodal data, whatever you need. This is the alternative. This is the API and the SDK interaction. So again, you have your API, you have all of the complex functions and databases. Nothing's changed there, but instead of the GUI, you have an SDK. And what I have here, what's exactly written in the code isn't as important as there are 16 different row spacing predictions with one click that get generated when this cell is run. And you can do, really your imagination is the only kind of limiting factor here. But when you click run on this cell, again, requests are sent, and then you can run as many functions, run as many things as you want with that one click, and you get the response back. And you can do whatever you want with that response. And so I hope that clears up a little bit of the mystery, kind of how the front end and the back end and the SDK kind of work all in tandem. I have now 3 examples, 3 case studies of how we are currently using this at PineGate. And so here we are. Here's example 1. And example 1 is looping over various parameters. And this is actually, we use this all the time. It's extremely valuable to us. The problem statement that we had was, well, we need to find a way to figure out which power plant configuration gives us the best yield. And so our solution was to build an SDK script that does the following. It clones a pre-built base in the GUI. And this is the example that I have a live demo of later. So I'll show you all of this when the time comes. You have a pre-built base, and that takes anywhere 5-10 minutes, so not long. You clone that pre-built base. You change one parameter incrementally. You can change more than that, but if you want to do it incrementally, you can just change one at a time. You run the energy model, and you save the result. And then you loop it. You repeat steps 2 through 4. And so what I have is an example of results there that we have, we called that our matrix. And in this example, 147 total predictions are run. And it took 45 minutes of total time, space time, whatever, like normal time. However, after the script was built and after it was after it was built and you have the script, it takes 5 minutes of man hours, 5 to 10 minutes that I mentioned earlier, because after you build the base, you click run and it does it all by itself. It just runs by itself. And so this has saved us a lot of time. Before we had this script, I know that it was taking us, we were using consultants for this purpose. And because this can be done with other solutions, but not in an automated way. It's very labor intensive. And so I know we were using external consultants, and it would take anywhere from 1 to 2 weeks for a turnaround. And so, you can do the math on how much time and resources that was costing, and now it's 5 to 10 minutes. So, I mean, this allows us to be very scalable and get results very quickly. So that's example 1, and that's the one I'll be showing you. Example 2, this is looping over locations. And this came up, we were kind of brainstorming, and we wanted to understand how PineGate would perform in new markets. And so North Carolina is not a new market for us. We're based in North Carolina, but I want to show one that we're already in for the purposes of this webinar. So here I have North Carolina there, and I built an SDK script that does the following. The inputs that it takes are locations. And in this case, it's a data set of latitudes and longitudes, which I found just online, freely available to anybody. And you can see in the heat map, it's on the county level. And it creates representative power plants in those locations. So I worked with our teams and I said, okay, what's the most average typical power plant that we are going to build? I ran the energy model and it saved the results. And again, kind of the theme with these type of things, or the theme that you'll see, is the automation, the looping, the repeating the steps 2 through 4. And for this one example, I think there's 100 total counties in North Carolina. And it took, for this state, 30 minutes, but after the script was built, it took, again, 5 minutes. All you do is you get your data sets ready, save it in the right location, and you run it. And so, it takes a while to build out the script. However, once you have it, this can now be replicated if we're considering, well, should we go into new markets? Let's get an idea of what sort of power plant we'll be able to build in those markets. And so that's that example, looping over locations. And so the final example that I'm sharing, and this one's currently in progress, it's not 100% built out yet, but it's one that we're working on, is we want to have a crisp understanding of our fleet performance. And so we have SCADA providers, and those have monitoring platforms, and those work very well. But what we wanted to do was pair it with the energy modeling capabilities of PlantPredict. And so our solution, which again is currently in progress, is to build a Python SDK script. And I put Python here in addition to SDK because the SDK, the software development kit, is particular to PlantPredict. So when I'm building something to communicate with a SCADA platform, or really any other API out there, you're using Python, just the scripting language, and the SDK is particular to PlantPredict. So that's why I made that distinction. You create that does the following. It downloads measured weather station data from the monitoring platform. So you have your pyranometer, you have your temp sensors, you have everything on the job site. And those get recorded. And at intervals that you choose, or that we're going to choose, it downloads them. For that same interval, it downloads the plant performance from the monitoring platform. The script then, all in one sweep, the script then uploads the weather and performance data into PlantPredict. It runs an as-built model with the uploaded weather data. It saves the result, and then it compares them. And you can compare them. It compares the measured meter production with the as-built model production. And you can then use, there's a lot of built-in Python modules and whatnot to generate intuitive reports and all these things that are automatically sent to all of your key stakeholders for that site or your fleet of sites. And what's also very cool about this is you can drill down not just on the site level, but depending on where data is measured, you can drill down to the inverter level. You can say, okay, inverter 6, based on irradiance data, we're seeing that it should be performing this and it's not. So rather than saying like our plant is underperforming, let's try to troubleshoot, you can generate a report that says inverter 6 is underperforming. So it's a lot more granular there. And so, yeah, that's kind of the 3 examples here that I wanted to talk about that we're currently building out and using at Pinegate. And so I have a demo, and we're going to go and do a Q&A. But the demo, I think I have ready here. So if we're ready to go, I can bring that over here. Actually, before I show the code, I want to show PlantPredict. So this is the GUI, as mentioned before, the graphical user interface. And everyone's seen this, but this is our project library. Click on Demo a Project, which I created for this purpose. And here I've created a base. As I mentioned, that base prediction, this is the one that will be cloned and run. And this is a pretty typical, it's on the smaller side. It's 20 megawatts, got a 1.4 ratio. It's a fixed tilt site. It's got a GCR 35. Very typical numbers here. And you can go to the power plant and take a look here. Inverter, these are all global parameters that I chose, global assets. But yeah, so this is a very typical site that we might have. And I have it built in the city of Raleigh. And so I'll have that there. And then this is the script. And so I'll do a quick walkthrough. I won't get into the too nitty-gritty because it was good to see that poll to know kind of the level of knowledge that we have here. So the point is not to like dig into the code exactly, but maybe just to understand what each chunk is doing. And so up here, you have to import your relevant modules. And so that's what's being done here, all your relevant packages and whatnot. Then you have your inputs. And so what I'm going to be doing here, as I mentioned earlier in the presentation, is looping over parameters, running the prediction, and saving results. And so the 2 parameters that I'm going to be looping over for this demo are tilt angle. So you hear min tilt and max tilt. I'm going to be going from 20 to 40 by 5s. And azimuth, the module kind of orientation. I'm going to be going from 150 to 210 by 10 degrees. And so that's what this section is doing. You're defining your inputs. And the last part, the last little chunk that we have here before we get to the actual sweep, which is down here, the last little part, what this is doing, this is where the SDK kind of shows up and it kind of gets brought up in the code. So what this is doing is it indicates which prediction we're going to be cloning. And so if we remember, it's going to be this one. So it indicates which prediction is going to be cloned. It then clones that prediction. And so what you'll see when we run this is in the GUI, you'll be able to see that cloned prediction. It runs that prediction. It then creates a local object or a local variable within this coding environment. This is a coding environment called Spider. So within Spider, it creates that local object that is essentially a local version of the prediction that exists within PlantPredict. And so you can access all the parameters, everything you'd ever need to access in a prediction or power plant, like you see here. Everything you'll ever need to access, you can access locally. Once you get it, you no longer will have to ping the database. And now, why is that important? Why do we want to do something like that? Well, that kind of gets into like object-oriented programming and type of things like that. But one of the ways that I think about it is if you fetch the entire prediction and bring it locally, you then don't need to know everything about it. You can just access the things you need to know, like in this case, tilt and azimuth. And the other reason I think about it is, or way that I think about it is, let's say that you and your friend want to complete a puzzle, and you live in one town, and your friend lives in another town, and you know how to put the puzzle together, but your friend has the puzzle. So how do you solve this problem? Well, one way that you can do it is this is assuming we don't have cell phones and we can't send text messages. One way you can do it is you get a letter, you write the letter, you go to the post office and you give it to the postmaster, he delivers the letter, your friend reads the letter and says, okay, this is where I put the first piece, puts the piece down. Your friend then writes a letter to you, gives it to the post office, brings it back to you and says, okay, next piece. And you repeat that. That takes a lot of time, especially if you have a 1,000 piece jigsaw puzzle. It takes a lot of time just in transit, just in the request and the response. So what this allows you to do is send one request, get the entire puzzle from your friend, then you can put that puzzle together, and you put it together and in whatever way you want. There's no delay, no letters, nothing like that. You then take the puzzle and you mail it back to your friend, and that's it. There's no more back and forth. And so that's another reason why you do something like this, where you create that local version. You create that local version of the prediction and the power plant, so you can manipulate it locally and then send the update back. So I know that might get a little technical. Hopefully I didn't lose too many people in that, but that's kind of what's happening here. Okay, so with that being said, that's what's happening up here. Now we get into the sweep. I won't walk through the sweep because that gets into some loops and logic, but essentially what this is doing is it's changing the tilt and the azimuth by 5 and 10 respectively. And then at the very end of that, this loop, what I do is I save it to my desktop as an Excel file, and then we'll be able to see that. And all of this is done, like I mentioned, all of this is done completely automatically. It's done autonomously, everything like that. And so, let's let's see, I hope I didn't drag anything around to make this not work. So it was working before the demo, so it should work now. But let's see. What I want to do is place this here and this here. So what I'm going to do is hit play, and you'll see in the console here little messages that indicate when a prediction is being run. And at the same time, you should be able to see in the GUI, for me, predictions being run. We'll see the clone, and I will have done nothing in the GUI. All I will have done is use the code. So let's click play. And you have a second here while it reads the file, it loads up, and yeah, so you see here, yep, it's already working. So prediction log 1, that means a prediction is being run. This is indicating we are running the 150-degree azimuth, and we're looping through that first, or we're looping through the tilt angles first. So we have 20-degree tilt, 25-degree tilt, all at 150 degrees. If we refresh this page, we see here, this one wasn't here. It is now here. This is the prediction that we are now looping, running, and saving the results in. And that was cloned from the base. And this will just keep running until it reaches the end of the parameters that we want to run. So if we go here to prediction log, you can see that this is running. And so, yeah, this will keep running. I think I have here it's a total of about 35 predictions that are going to be running, and you see that all I did was click play, and now it's going to run. So yeah, that's kind of what's happening. And so I think maybe I wanted to kick it back to David for either some of the Q&A or maybe something else while this is running, and then when it's done, we can take a look at the results.
Yeah, so what we'll do now is while that is running, because it will take a few minutes, I'm going to talk a little bit about the announcement that I have to make. So let's see here. Tricia, can you make me the presenter? All right. All right, at this point, I believe that you are seeing my screen. Okay, so we are making an announcement today. That's a pretty big deal. So we've changed how we are licensing our API predictions. We used to offer the API predictions in a way that if you were a business subscriber, you got 100 free predictions a month, and then you would get charged 10 cents per prediction for every prediction after that. And then for enterprise, you would get 1,000, and it was just a complicated and confusing process. We are suspending that cost per prediction. So effective today, we will no longer be charging on a per prediction basis. The way it's going to work is if you are a business subscriber to our PlantPredict Premium package, you will get access to the API. Or if you're an enterprise subscriber, you will get access to the API. We still don't offer it for just the pure individual PlantPredict Premium subscribers. So if you are just an individual who wants access to the API, you will have to subscribe to the business package in order to get that access. So there is an additional fee in order to get that capability, but that's because the API does provide such a powerful capability. So that's a pretty big switch. One other thing that I wanted to showcase for everybody here is you may be wondering, like, how do you even get started? And so if you open up Google and and type in PlantPredict SDK in your search, the very top result that's going to come up here is the Python SDK for PlantPredict API. So that's all you have to do is type in PlantPredict SDK. And when you get out here, this is where all the documentation for the Python SDK is, and it's a really well done. Give credit out to Steve Kaplan. I know he's on the call. He was the guy that really was instrumental in developing this, and he did a fantastic job and laid this out in a way that you can start right off with installation and setup. It talks through how to do the installation. And then we do have a section in here about API authentication. A very important aspect of accessing the API is you've got to get API credentials. And the API credentials can be issued by your company administrator. So that's the reason why you need a professional business package, is because that's the level at which you start getting company administrator capabilities. So a company administrator is able to issue the API credentials, and then you embed your API credentials into your Python script in order to be able to access the API. Something that I think is really important is we have this SDK reference. So this gives a reference to all the different commands that are available in the SDK. And then really handy is the example usage. So in this section, you get actual code that you can use to get up and running and get started and get using the Python SDK, or get started using the API connection. And so we have a few different, you have just creating a project prediction from scratch is a place to start. Modeling your power plant, downloading your nodal data, cloning a prediction. So we saw Jacob is using that in today's demonstration. Changing the module in a power plant, changing a predictions weather file. That was one of the scenarios that Jacob talked about. Uploading raw weather data, generating a module file, and then setting up predictions monthly factors like albedo, soiling loss, or spectral loss. So the code for these scenarios is available out here in the SDK documentation. And so for anybody that's on this webinar that is joined in this because they want to take advantage of the PlantPredict API, this is the place where you're going to want to go to start. Once again, you just go to Google, type in PlantPredict space SDK, and the very top result that will show up will take you to this read the docs location. All right. So with that being said, I am going to hand it back over to Jacob so he can show us the results. All right. So I will stop sharing my screen.
Great. So let me go ahead and share mine. And let's see. I want to share this one. And as David mentioned, all of that is there. All right, there we go. All of that information is there, and that's what I used. I used all of that reference material online, the example usage. Getting started, there was a lot of copying and pasting those examples, and just really doing that and messing up for a long time. You know, just like making errors and figuring it out and iterating myself, iterating the code and slowly changing things. And you start to learn, like we've all had so many, oh, it looks like it's finished. We've all had so many years of using graphical user interfaces that we know how to use it. And we're very familiar, and it's very intuitive to us. And they're made to be intuitive. And we all haven't had years of using of coding, or some of us have, but not most people haven't. And so just figuring it out, understanding, making mistakes, iterating, and slowly getting to where you need to go it's all a part of it. And that example usage online is excellent, and it's where I got started too. And then I'm sure David and I have talked about this before, like we're here to answer any of those questions or help out. I think my email was on the slide. It's jjackson@pgrenewables.com. I'm happy to answer any kind of like setup questions or basic questions. I want people using this. It's a very cool, useful tool that is kind of not really seen anywhere else in the industry. So yeah, with that being said, let me bring up the results. They should be saved here on my desktop, and they are. All right. So here are the results. I did this again with one click. It took 1 minute to boot the program up and 20 seconds to look at the code and click the play button. But as we can see here, let me give it a little conditional formatting so we can get a better idea. And these results are they're what we would expect. So there's nothing kind of groundbreaking in terms of the results here. But what it does show you is how quickly we made, go ahead and, how quickly we made 35 energy models. I mean, think about that, how long that would take if you were using even the graphical user interface of PlantPredict. You could do it pretty quickly, but not that quickly. And if you use other softwares out there, it would take much, much longer to run 35. And so here we can see that the results, which are intuitive, 30 degrees and 180, but imagine you were iterating over some other parameter that's not so intuitive. Like imagine you're doing your plant output limit, your point of interconnection, like, and you have a fixed DC. You don't really know like where that's going to be the highest. And if you overlay that with things like how many acres you have to build, and it's really just your imagination here is kind of the only limiting thing. And so that's kind of, oh, it looks like this one's actually the highest at 25. But anyway, so that's kind of the whole point, is how easy this makes iterating. And if you come up with something, you can really bring it to life using the SDK and the API. And this took, you can look down here, I have the runtime down here. This took 6 minutes. 6 minutes of runtime, 30 seconds of man hours to generate all this. So yeah, so that kind of wraps that up for me. Yeah.
All right, Jacob, we do have one more poll question. So Tricia,
Sure.
Why don't you queue up the next poll question, and then we'll transition over into Q&A.
Great.
All right, so the next poll question says, assuming no constraints on time or manpower, how many more predictions would you run on a typical project? So if you had the ability to script it out and just let it run, would you just continue to do the same thing that you've been doing and run the same number of predictions? Would you do 2 times the predictions? Would you do 3 times, 5 times, or even 10 times? Go ahead and let us know what you're thinking on that, and we will review the results here in a moment. All right, I'll share the results. So there it is. I think that it's unanimous, or nearly unanimous. It's definitely obvious that people want to run more. They want to run more predictions, and that's the whole idea here. Is if you can run more predictions, you can do more analysis. And so the beauty of the Python SDK is that it does set you up to be able to run predictions very quickly, very easily. With that being said, I think we're going to transition over into the Q&A portion of this. So, Jacob, your screen is still showing. Why don't you bring up the presentation? We'll go to the Q&A slide. All right. The first question that has come in, Jacob, is it looks like running the process takes up your computer resources. Is there a way to schedule the running of a Python script?
I'm unmuted. Good. There are ways to schedule. Let's say you want to run something at 3 a.m. or something when resources and maybe internet bandwidth are the lowest. And particularly, I can think of like you can schedule these sweeps, or you can schedule like maybe the SCADA example. You want to do it on a daily basis. Maybe you download the previous days at 3 a.m. and have it all set up to where the report's sent out, so everyone has it in their inbox bright and early when they get in. you know, whatever you want to do. There are ways to do it. I will say I don't have any of that set up right now. It's something that I do want to set up. So it's funny that you bring that up. I do want to set it up with that example that we're building out with the SCADA provider. I can't tell you exactly how to do it right now, but I'm sure like if we did a little research and look those examples up, we could figure out ways to schedule it. So long-winded way of saying that, yes, there are certainly ways to schedule those scripts.
All right, very good. Okay, next question is, how long does it take someone with your Python experience to create a script for like example 1 or example 2? And this is including error checking. So give us the honest answer, like how long does it take?
And including debugging and all that stuff. Yeah, so let me think about it. So if it's brand new territory, so if it's something that, like if I'm creating a new script that loops over parameters, like if it's something we haven't done before, but we've done something similar, then it doesn't take that long because you can reuse code. Like it's one of those things that why redo work that be more efficient? Why do you redo work? So if it's something that's close to what I've done before while still being new, maybe about a day, maybe a little longer for the debugging. You know, you set it up, you answer a few questions on you know, your chat program, you come back to it and you work on it. So probably about a day to set it up, and then maybe another day to debug, and then it's done, it's ready to go. If it's something brand new, completely brand new, then maybe on the 3 to 4 day time scale to a week. And that's not working on it 100% of the time. That's, you know, answering emails, putting out fires, doing other things, and then coming back to it and maybe dedicating 2 to 3 hours a day to work on it. With that bandwidth, probably about a week. But it's a very good question.
Yeah, and that's the beauty of that is once you have it scripted, you have it scripted. So then you build a library of scripts, and the value just almost has like exponential value for you.
Yeah, that's exactly right. It's there will always be that initial lift of creating the script for whatever purpose that you're doing, but it's one of those things where you put in the work up front, put in the, like, you know, the creativity, you meet with your colleagues, you figure out what you want to do, you put in the work, you invest that time up front, and then you have it forever, but until things change or until you want to change something. That's how you build, you know, a scalable model.
You know, so one of our attendees sent in a message as a question to help out. So in the previous question where we talked about scheduling the running of the Python script, Justin said you can save a Python file as a batch file, and then within Windows Scheduler you can allow it to run at specific times. So that's a little tip for you and for the rest of the participants.
That is awesome. Yeah, thank you for sending that in. That's great.
Yeah, it's really good. All right, so Kristen said, you know, thanks for the presentation. Appreciate that, Kristen. Can you speak a little bit more to the added benefits of the PlantPredict SDK versus just using Python or even like another programming language? Like why the SDK?
Yeah, because, and to that point, Python has a built-in requests library, request module. And so what you can do is, and you can totally do all of that. You can write a script in which you import the requests module, and then you use that module to send individual API requests. And so that can also be found online. It can be found, there's a link to it on the PlantPredict website that I've used. And so that API documentation is there separate from the SDK documentation. And so what you do is you use that Python request module, you input the API commands, API requests into there, and then you can run it that way. I have found that using the SDK is much faster, and for reasons that I touched on a little bit in the script. But if I get the entire power plant, I can then choose to manipulate the power plant and the prediction locally, like in my environment. And that power plant object, that power plant kind of like data object variable that's there, you can go and create a custom one in Python, but you might as well just use the ones that Stephen Kaplan, again, another shout out to Stephen Kaplan created, and use the objects that are in the SDK, because what that object has, you define that variable as power plant or whatever you want to name it, and then it has all the parameters that you would ever need within that object, and you can change the tilt angle, you can change the loss factors, you can change everything about it locally, and that's instantaneous. That doesn't require that request to then be sent each and every time you want to change one tiny little parameter. And there are other reasons that you'd want to do that, but it's really gets into more of like limiting the number of requests sent back and forth, because that's like the loading time on Facebook. When you click a button and it spins for a second and then you see it, it's not that long, but it can, if you're changing a lot of things, it can take a while. And then it also gets into kind of object-oriented programming. You create that object locally, you can edit what you need, and without needing to know the entire structure of the power plant, and then update it. And so all of that being said, that's why I think using the SDK is very useful, and it's why I've invested the time to learn it. But to this asker's point, you can totally do all of this with just Python or just some other language by using whatever that language's version of sending requests. You can do this using Postman, which is another kind of API GUI that you can download. So there's lots of different ways to do it. I've just found that this is the fastest for me.
All right, very good. So we do have an admittedly rookie question from the question asker, which I like. Anaconda versus Spider. Can you talk a little bit about what those are?
Yeah, Spider is an IDE, an independent development environment. I think that's what it stands for. But the development environment that you use, I mean, there are a lot of different options to do that. There's PyCharm, there's Jupyter Notebook. Jupyter Notebook's a really good one if you want to make something that's very technical and has code in it, but at the same time you want to present it to maybe like executives, or you want to present it to the rest of your team. An IDE with like Spider or PyCharm, it's very intimidating. It doesn't show, it just shows code and that's it. Jupyter Notebook is another option to that, and you can write code, you can put comments. It kind of looks like a codier version of Microsoft Word. So yeah, those are all different places to write your code. Anaconda is the Anaconda distribution of Python and the Anaconda Navigator. Here, I'll go ahead and drag it over so you can see it. But this is the Anaconda Navigator here. This is something that you download that it has all of these programs and applications built into it, and it also installs the most recent version of Python, because Python is actually something that you need on your computer. It installs all of that for you, and so you have this kind of all-in-one built-in thing that you can use. And so you see here I have Spider, which I can launch, PyCharm, here's the Jupyter Notebook that you can launch, and it has all these other things. I haven't used most of these. These come kind of stock with Anaconda, but you can download the Anaconda distribution of Python. You get Python, and then you get all these other things that you can then use to code. And so that's a very good question and a very good kind of distinction there.
Yeah, I would say Anaconda is like a distribution network, and Spider is an IDE. Is kind of like how I would think about it.
Yeah.
All right, here's a question that's come in. So uh, how is this different? So the SDK or API integration, how is this different from build a batch of predictions feature in the GUI?
Yeah, that's a good one. And the short answer is it's not necessarily different in that you can build a batch of predictions through the GUI. And so, and what this question is referring to is, you know, when you make a prediction, you can build it either block builder, map builder, or build a batch. And so when you build a batch of predictions through the GUI, you define parameters like your module, your inverter, your weather file. You choose tilt angle or tracker. You know, you build a very basic outline of a prediction, and then you can choose up to 2 variables of 4 potential options. You can choose those and then iterate over those. And now you can only do, at least the last time I did it, you can only do, I think, up to 350 at a time.
Yeah,
I don't know.
Yep.
Yeah, I don't. Yeah, okay, yeah. So yeah, you can do that. And so it's kind of one of those things where all squares are rectangles, but not all rectangles are squares. So like the batch prediction is kind of you're running a bunch of different predictions all at once and iterating the parameter using the SDK and using the API through the scripting language of like Python like this. It gives you you have no limits. So you don't have any limits on the number of predictions you can run. You can literally change any parameter of a power plant, and there are so many. There you can change the plant output limit, you can change loss factors, you can run, you know, 10 different modules all at once. You can run. There is no limitation. The only limitation is kind of what you can come up with and what your company find useful. And the GUI is a lot more constricting in that sense.
Yeah, I think it's important to, not everybody's into scripting. And so the batch builder capability does allow people the ability to do a lot of simulations very easily.
Yeah.
But you know, we created the batch builder really before we had the SDK. And when Stephen put together the SDK and we started seeing the power of the API, it kind of demotivated us to really extend the batch capability because we could do so much more with the API. So that's really been our approach. And we still support the batch builder, and we are going to continue to make some improvements on it because not everybody wants to do the scripting, but
Totally.
so much more powerful using the API. We had another comment come in from an old friend, Uday. I think you probably remember Uday.
Uday, I do, yeah.
Integrated development environment. Come on, man. So
I said, as I was saying what it stood for, I was like, I think that's what it is, but I'm not sure. So Uday, you caught me. Thank you for that.
All right, another question. So does the SDK work when a prediction is in map builder mode, or does it need to be in block builder, since so much of the map builder requires GUI controls?
This question I'll answer, but I might kick it over to you a little bit, David, too.
Yeah, I can answer.
Yeah,
that.
go ahead and take that one.
Yeah, unfortunately, the map builder, the tools we use for the map builder is very much done in the GUI. It's all done inside the browser, and it's all client side logic. So unfortunately, there's no way to through the API create map builder predictions. That's a real unfortunate limitation that we have based on the choice we made for the technology. I mean, the technology we use for the map builder is really cool and it's very powerful and it's very fast, but that is one issue with that. So yes, you do have to approach API predictions from the block builder perspective. So create your prediction, your base prediction in the block builder, and then go from there. In a way, like your scripting is kind of doing the same thing that our map builder does. So when you create a map builder prediction, when you run that prediction, it gets converted over to a block builder, and our energy prediction engine only recognizes power plants when they're in the block builder format. So in a weird way, like the map builder is just another GUI, to use Jacob's presentation concepts. It's a GUI that creates a block builder prediction that can then be run through the prediction engine. So that is the answer to that. We do still have a little bit of time. So there was a question, and it's more of a request. Would it be possible to share an example of the measured output versus the simulated output? Just curious what the output would look like.
The measured output versus simulated output?
I think data example.
Oh, okay. I do not have that ready to go for this demo. So I apologize. It would have been a cool thing to see. But I think, as I mentioned in the slide, I'm still working on that script. So it's not quite ready.
All right, maybe that's a good addition to our SDK documentation, as we should get something like that out there as a sample code.
Totally.
One thing I do want to point out, so the SDK is open source, so it's logged on GitHub, and we do look to the community to contribute. Not a lot of community members contribute to that. We always get questions about whether we're going to be continuing to update it. Well, we look to the community to update it. So for those of you who are Python, we had quite a few that consider themselves experts or advanced. For those of you, you are welcome to continue to contribute to the SDK. We would appreciate that. So that's just a little plug for that. All right. And one last question. This is the last question, Jacob. So
sure.
When it comes to measured plant data, how do you handle quality control?
Oh yeah, that's a big thing that I know we deal with at Pinegate, our asset management team, performance engineering team. The quality of the data that comes in, which I'm assuming is what the question is kind of referring to, is can be a pretty big issue. If the results that we see don't make sense, if we know that a POA sensor went down, then we go in and we manually inspect these things. We figure out if the POA sensor, the tracker that the POA sensor is stuck at horizontal, or there's really not a good answer, or I should say like an elegant answer to that. We're working on things here, but it's really just figuring out if the data that comes in is of good quality, and if not, then massaging the data to make it useful to us. But unfortunately, there's no really good, elegant solution to that, other than, if whatever hardware you're getting isn't good, then maybe consider a different hardware provider. We've definitely looked at many different ones and made decisions based on quality and that type of thing.
Very good. Well, Jacob, thank you so much for taking the time to put together a webinar for us and to showcase a little bit of what Pinegate is doing. And it's really valuable for our community and for our users. I know there's a lot of interest. We had just an unbelievable response to this. And for all of you who joined in today, I appreciate you taking the time, and I look forward to seeing where you guys go with this and what you can do. But this is about all the time we have for today. So thank you to those who attended, and a special thanks to those who submitted questions. We had a really good slate of questions that came in. If we didn't get to your question, we will go through these questions and see what we can do to get you a response. But you are always free to contact us. You can contact us at support@plantpredict.com. Just send an email to support@plantpredict.com. We man that 24 hours a day, and we will get you a response. And I also just want to put a plug out there for PlantPredict.com, where you can get a lot of your questions answered directly there through our online documentation. And then, of course, the SDK documentation is very, very helpful as well. So with that, we'll conclude today's webinar. Thanks again to everyone for joining. You'll be getting a email with the recording very soon, so look forward to that. Thank you very much.